Hello class, my name is Kavita Tiwari and we are going to start a chapter of class 9 which is matter in our surroundings. And in this chapter we will be having some subtopics which are physical nature of matter, characteristics of particles of matter, states of matter, then comes the can matter get changed in can matter change its state and evaporation. So let's get started. Physical nature of matter. So you must have known that matter is made up of particles. Let's say for a long time two schools of thought prevailed regarding the nature of matter. One out of them believed matter to be continuous like a block of wood, whereas the other thought that matter was made up of particles like sand. So there was an experiment performed to check this, that they performed it to decide the nature of matter, whether it is continuous or particulate. So they took out the experiment, and after that they found that the matter is made up of particles, and these particles are very small. They are as small as, like, we can't imagine. Okay, so basically matter is made up of particles, and everything around us is made up of tiny pieces or particles which are very small, and they do exist. I mean, matter do exist in three states, which is solid, liquid and gas. Okay, then our next subtopic is characteristics of particles of matter. So characteristics of particles of matter, it has been divided into two parts again, which is particles of matter having space between them and particles of matter attract each other. Particles of matter are actually continuously moving, so they possess kinetic energy between them, and when the temperature rises and the particles moves faster, so we can say that with the increase in temperature the kinetic energy of particles also increases. Okay, let me write here for you that when temperature increases, the kinetic energy also get increased. So it is done that particles of matter have space in between them. Let's say an activity has been performed. So the particles of sugar, salt, Dettol or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee or lemonade, Particles of one type of matter get into the spaces between particles of other. This shows that there is enough space between the particles of matter. Okay. So we will remember the example of salt get dissolved in water or sugar get dissolved in water. For the particles of matter have space in between them. So when the particles of matter intermix on their own with each other, they get they get in the space between the particles of other thing. So this intermixing of particles of two different types of matter on their own is called as diffusion. Okay. So let me again write here that the intermixing of particles of two different types of matter on their own is called diffusion. And we can observe that when we heat this intermixes part, it get faster. I mean, when you boil the water and then mix the sugar, the sugar will get dissolved faster. So when we heat, the diffusion becomes faster. Okay. On heating, diffusion becomes faster. Let me make a bigger size of it for you. Okay. So why does this happen? Why on heating diffusion becomes faster? Because particles of matter attract each other. The second part of this is particles of matter attract each other, and this is the reason why diffusion becomes faster on heating. All right. So basically we can see an activity which was performed, that play a game in the field, make four groups of form human chains as suggested. The first group should hold each other from the back and lock arms like some dancers, and the second group should hold hands to form a human chain. The third group should form a chain by touching each other with only their fingertips. Now, the fourth group of students should run around and they will try to break the three humans chain by one into as many as small groups as possible. So, what do you think, which group was the easiest to break and why? Obviously, the group which was formed by just touching each other's fingertips would be easiest to break, because there is not a strong force of attraction between them. So, it will be separated easily. Okay. So, we are done with this characteristics of particles of matter. Now, let's move to the next part, which is states of matter, the most important topic in this chapter. States of matter, we all know that there are three states of matter and they are solid, liquid, and gas. We observe different types of matter around us. So, what are these different states? These states are solid, liquid, and gas. These states of matter arise due to the variation in characteristics of particles of matter. Okay. So let's study about the properties of these three states of matter in detail. Let's start from solid state first. Okay, let's have an idea of an activity. So collecting some articles. These are a pen, a book, a needle, and a piece of wooden stick. Now sketch the shape of the above articles in our notebook by moving a pencil around them. So do these have a definite shape and distinct boundaries and a fixed volume? And what happens if they are hammered, pulled or dropped? Would they be capable of diffusing each other? What do you say? So all of these are examples of solid. A needle, a pen, a book, a wooden piece, stick. These all are the examples of solid. So we know that these have definite shape also, distinct boundaries also, and some kind of volumes. So solid have a tendency to maintain their shape when subjected to outside force, and it may break under force, but it is difficult to change their shape, so they are rigid. Okay, let me write here. So that it would be easy for you to remember. Solids have definite shape, distinct boundaries, some fixed volume, and although negligible but compressibility. All right, and they have tendency to maintain their shape when subjected to an outside force. They may break under high force, but it is difficult that they change their shape. So, solids are rigid. Let's consider, what about a rubber band? Can it change its shape on stretching? So, is it a solid? We know that a rubber band get easily changed. Its shape of it is getting easily changed when we stretch. So, actually, it is solid because when we stretch it, it do change. But when we throw it, it again come in its regular shape. So a rubber band change shape under force but remains regains its same shape when higher than that of solid. So this is due to the fact in the liquid state particles move freely and have greater space between each other as compared on particles in the solid state. All right. Now let's talk about the gaseous state. So, talking about the gaseous state, the first example in my mind is balloon. Have you ever observed a balloon seller filling a large number of balloons from a single cylinder of gas? It inquired from him how many balloons is he able to fill from one cylinder. So we can ask, which gas does they have in the cylinder? Right. So if I say take three 100 milliliter syringe and close their nozzle by rubber cocks as and then remove the pistons from all the syringes, leaving one syringe untouched. Fill water in the second and pieces of chalk in the third. Then insert the pistons back into the syringes and you may apply some Vaseline on the pistons before inserting them into the syringe for their smooth movement. Now, if you try to compress the content by pushing the piston in each syringe, what will you observe? And in which case will the piston easily pushed in? What do you think infer from your observation? So, from this, we may observe that gases are highly compressible, and compared to solids and liquids, they are the liquefied petroleum gas cylinder that we get in our home for cooking or oxygen supplied at hospitals in cylinders is compressed gas. Compressed natural gas, that is CNG, is used as fuel these days in vehicles also. And due to its high compressibility, large volumes of gas can be compressed into smaller cylinders and transported easily. We know what is being cooked in the kitchen without even entering there by the smell that reaches our nostrils. How does this smell reach us? The particles of the aroma of food mix with the particles of air spread from the kitchen reach us and even farther away. The smell of hot cooked food reach us in seconds. Compare this with the rate of diffusion of solids and liquids. Due to high speed of particles and large space between them, gas show property of diffusing very fast into other gases. Okay. So in gaseous state, the particles move about randomly at very high speed. and because of that movement the particles hit each other, also the walls of container. The pressure exerted by gas is because of this force exerted by gas particles per unit area on the wall of container. So the key points which we observed from this discussion are that gases are highly compressible. And in this stage the particles of gas are moving randomly at very high speed because of free space between there, and due to its high compressibility large volume of gas can be compressed into the small cylinder and transported easily. Let's talk about the liquid state. So what do you think about this liquid state? If I say, I told you to collect some water, cooking oil, milk, juice, and some cold drinks and container of different shapes. If you put a 50 milliliter mark on these containers using a measuring cylinder from the laboratory. So what will happen if these liquids are split on the floor? Does the shape of liquid remain the same, or does the volume remain same? When you pour the liquid from one container to another, does it flow easily? So what happened? The liquids have no fixed shape, and as it does not have any fixed shape but it has a fixed volume, they take up the shape of container in which they are kept. Liquid flow and change shape, so they are not rigid but can be called fluid. We all know that the gases from the atmosphere diffuse and dissolve in water. So these gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. Right? All these creatures need to breathe for survival. The aquatic animals can breathe underwater due to presence of dissolved oxygen in the water. So we may conclude that solid, liquids and gases can diffuse into liquids. The rate of diffusion of liquids is higher than solid, and this is due to fact in the liquid state particles move freely and have a greater space between each other as compared to the particles of solid state. So what are the key points in this in the discussion of liquid state part? That liquids are not rigid. It has no fixed shape. All right. It can be called fluid. The rate of diffusion of liquid is higher than solid. and the particles of liquid moves freely. And have a greater space between each other as compared to the particles of solid. So this was all about the three states of matter: solid, liquid and gas. Okay, so we are done till here. Our next subtopic is, can matter change its state? What do you think about it? We know that water exists in three states of matter. Water exists in the form of ice also. As solid, we can say water is in the state of solid, water is ice. In the form of liquid, water is water itself. And in gas, we can say water as water vapor. So what happens inside the matter during this change of state? And what happens to the particles of matter during the change of states? How can this change take place and how do this all happen? What actually happen? There is an effect of change in temperature, right? And other factor is effect of change in pressure. Okay. When pressure changes, when temperature changes, matter changes its state. Okay, and how does this all happen? Let's say you are performing an activity, you take about 150 gram of ice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with the ice. Then you start heating the beaker on a low flame. While heating, you know that the temperature is getting raised. So the temperature when the ice starts melting, you will note that, and the temperature when all the ice has converted into water, you will note that. Then you record your observation from this conversion of solid into liquid state, and after that you put a glass rod on the beaker and heat while stirring till the water starts boiling. Then you keep a careful eye on the thermometer, reading till most of the water has vaporized. So you record your observation for the conversion of water in liquid state to gaseous state. So you can know that when you increase the temperature, the solid increase the temperature of solid, the kinetic energy of particle also increases, and because of this kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the force of attraction between the particles, and the particles leave their fixed position and start moving freely. So when they are reached a state when the solid melts and is converted into liquid, the minimum temperature at which the solid melts to become liquid at the atmospheric pressure is its melting point. Okay. So one more thing we have got from this is that what is a melting point, and melting point is it's an the melting point of a solid is an indication of force of attraction between its particles. Right? Now, the melting point of ice is 273.15 Kelvin. The process of melting, that is change of solid into liquid state, is known as fusion. What is fusion? The process of melting So when a solid melts, its temperature remains the same. So what do you think, where does the heat energy go? You must have observed during the experiment of melting that temperature of system does not change after melting point is reached till the ice melts. This happens even though we continue to heat the beaker, that is we continue to supply heat. This heat gets used up in changing the state by overcoming the forces of attraction between the particles. Simply we can say that we reach to liquid state from solid state by heating, and again by heating we reach to gaseous state from liquid state. And similarly, if we do the reverse process, if we cool the gaseous state, it will convert it into liquid, and if we cool the liquid state, it will get converted into solid state back. So we infer that state of matter can be changed into another state by changing the temperature, right? Next is change of pressure, effect of change of pressure. So we already know that the difference in various state of matter is due to the difference in the distance between the particles from each other. If we start putting pressure on a compressed gas enclosed in a cylinder, what will happen? Will the particle come closer? So do you think that increasing or decreasing pressure can change the state of matter? For this, let's apply pressure and reduce temperature. So can it liquefy gas? Yes, definitely. Applying pressure and not reducing temperature can liquefy gases. Have you heard of solid carbon dioxide? It is stored under high pressure. Solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Thus, we can say that the pressure and temperature determine the state of a substance, whether it will be solid, liquid, or gas. Okay, and we have a small trick to remember this, as we convert solid we convert solid to liquid by fusion and liquid to gas by vaporization. Again, we do sublimation to convert gas into solid, and going reverse. Okay, sorry. We convert gas into solid by deposition, and going into reverse, if we do sublimation of solid, it will be converted into gas. If we if we do condensation of gas, it will be converted into liquid, and if we do solidification of liquid, it will be converted into solid. So they all are interconnected with each other. Now comes the last topic, that is a subtopic of today's session, which is evaporation. What is meant by evaporation? Do you have any idea? Let me tell you. Do we always need to heat or change pressure for changing the state of matter? Do you have any example from our day-to-day life where change of state of from liquid to vapor take place without the liquid reaching the boiling point? Water. When water is left uncovered, slowly changes into vapor. Wet clothes dry up in the presence of sunlight. What happens to water in the above two examples? We know that the particles of matter are always moving and are never at rest. At a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy, and in case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into vapor. This phenomenon of change of liquid into vapors at any temperature below its boiling point is called evaporation. So basically, evaporation is a surface phenomenon, and particles from the surface get enough energy to overcome the force of attraction present in the liquid and change into vapor state. What are the factors affecting the evaporation? The factors which affect the evaporation are increase of surface area, increase in temperature, decrease in humidity, and increase in wind speed. Let me write here for you. How? How these factors affect the evaporation? Let's say we know that evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. Let's have an example. While putting cloths for drying up, we spread them out. So when the surface area is increased, the evaporation is affected. For the temperature, with the increase in temperature, more number of particles get enough kinetic energy to get into vapor state. When humidity is decreased. Basically, humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. And when the wind speed is increased, it is a very common observation that clothes dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Alright, so this was all for today's lesson. Let's have a quick reflection of what we learned in today's session. Let's reflect what we have learned. So basically we started from matter in our surrounding. Matter, what is matter, and how they are. Matter is actually made up of some small particles which are very small beyond our imagination. There are three states of matter which are solid, liquid and gas. Then we learnt about the force of attraction. Force of attraction is maximum in solids. It is somehow intermediate in liquids and it is very less minimum in gases. And the kinetic energy of particles are very less, that is minimum in solid, intermediate in liquid and maximum in gas. States of matter are interconvertible. We can convert from a solid to liquid state and a liquid to gaseous state and also get back the solid state from gaseous state too. So states of matter are interconvertible. We can change temperature or pressure to change the state of matters. Then we learned about the sublimation. It is the change of solid state directly to gaseous state without going to the liquid state. And by boiling the particles in liquid, it changes into vapor state. Then we learned about the evaporation. Evaporation is actually a surface phenomenon and it depends upon the factors which affect the evaporation are rise in temperature, rise in surface area, decrease in humidity and increase in wind speed. Evaporation do causes cooling also. So for this last one, the cooling part, evaporation causes cooling, we will learn about this in our next lecture. And this was all for today's class. Alright, we will meet again in our next class. Till then, you guys take care and enjoy your learning. Have a very good day. Bye bye.